Example 5 for using FOIL. This is an alternate technique for double distributions. It doesn't work with any triple distributions or anything like that. That's why we originally learned the distribution idea. On this example, I thought I'd try to mess with you a little bit. I'm going to make it so that the variables don't line up. And so I'm going to say something like 2x minus 3 times 4y plus 7. Notice that in those binomials, it doesn't have the same structure as we saw in the previous examples. Let me pull that worksheet up here. You see how on this example it went AB, up here it was an x and then a constant, x and a constant. With this one, they don't line up. And so when I do my FOIL process, it doesn't change the technique. I still do first with first. However, when I do this one, I notice that they're not going to be a squared term. So 2x times 4y would be 8, alphabetical order, xy. And then when I move to the outer, 2x times 7 would be 14x. Inner with inner would be negative 12y. As I look at those labels, they are not the same, so I cannot add or subtract them, meaning that I would actually have to list both of those out. I say plus 14x minus 12y. And of course, we need to finish with last. Negative 3 times 7 would be negative 21. Notice that I ended up with 4 different terms here. That happens. It's not the end of the world, and I know it was going to happen, or I knew it was going to happen. I could predict that because these were not lining up as in the previous examples. Something else that can happen, this would be example 6 here. We have things that are called special products, and I'll talk about that in our next set of videos. But if you're trying to FOIL, you may get something like this. And so they do match up. I have x's and y's, x's and numbers, x's and constants. When I try to do the FOIL, first with first, 3x times 3x produces a 9x squared. And then the outer with outer, 3x times 2 would be 6x. Inner with inner would be negative 2 times 3x, which would be negative 6x. They have the right label, so it permits me to combine them. When I combine them, they are equal but opposite in value, so 6x take away 6x drops out. And so I don't have this middle term I'm used to seeing. And of course, to end this, I go negative 2 times 2 would be minus 4. And so in this series of examples for number 5 and number 6, when you're doing the FOIL, we notice that we don't necessarily guarantee that you're going to get 3. It's just an expectation of getting 3 terms in your answer. Let me explain that a little further here. Let's go back to our previous examples. So binomial by binomial, I get 3 terms. Binomial times binomial, I get 3 terms. Example 3, binomial times binomial, I get 3 terms. Binomial by binomial, I get 3 terms. That's what you expect to get. Okay? When I go to these problems here, for example 5, I didn't have that same symmetry in the binomials. I didn't have an x and an x. I had an x and a y and then 2 constants. That ended up producing 4 terms. That was exceptional. For example 6, I had the same terms, different signs, and what happened was the middle term dropped out, so here was an example where when I multiplied my binomials, I only ended up with another binomial. So the whole point to all of that is you expect 3 terms, but it is possible to get more or less. So sometimes you get 4, sometimes you get 2. That's the technique known as FOIL.